Good evening. This is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. Today I am going to deliver a topic transformer from the subject Basics of Electrical Engineering and Instrumentation. So we are going to see about the transformer construction and working principle. First, what is a transformer? So, transformer is a static electric machine which transforms electric power from one circuit to other circuit without any change in the frequency. So, it can increase the voltage or decrease the voltage with corresponding decrease or increase in current. So, if there is an increase in voltage, we call it as a step-up transformer, whereas in case of decrease in voltage, it is done by the step-down transformer. And next is the working principle of transformer. So it consists of a primary winding and secondary winding, and the primary winding is get connected to the source and the secondary winding is get connected to the load. So the basic principle behind the transformer is when two coils are mutually coupled or inductively coupled, if there is any change in one coil will causes a EMF generation in the other coil. So the current change in one coil will produce a EMF in the other coil. So basically a transformer consists of two inductive coils, primary winding and secondary winding. They are electrically separated but magnetically they are linked to each other. So here, as I told you, the primary winding is get connected to the source and the secondary winding is get connected to the load. So primary winding has n1 number of turns and the secondary winding has n2 number of turns. So if when a primary winding is excited by a alternating voltage, it circulates an alternating current. So this produces a alternating flux which links with the secondary winding. As flux is alternating, according to Faraday's law of electromagnetic induction, the mutually induced EMF is get generated in the secondary winding. So DC supply cannot be used for transformers as transformer works on a principle of mutual inductions for which current in one coil must change uniformly. If DC supply is given, current will not change due to constant supply and transformer will not work. So next is a construction of a transformer. It consists of a oil conservator, breather, and it consists of terminals and bushings. So we can see what are all the parts that is involved in the transformer. So first one is a core. So core is made up of a high grade silicon steel lamination and it is used to carry the flux that is produced by the winding. So winding is one which wounded over the core. So core is made up of a silicon steel. It is get laminated. Second one is a limb. So the vertical portion of this core we call it as a limb. So only on the limb the winding is get wounded. And next third one is a yoke. So yoke is a top and bottom portion of the core. So vertical portion we call it as a limb and the top and bottom portion we call it as a yoke. Yoke is used to carry the flux in one winding to other winding. So limb is one which carries a winding and yoke is one which carries a flux from one winding to other winding which is generated by the windings. Next is the winding. So coil used are wound on the limbs and they are insulated from one another. So used to carry the current and it produces the necessary flux for functioning of the transformer. So flux is produced by the winding. The winding is get wound over the limbs. And next is a conservator. So oil in the transformer expands when temperature inside the transformer increases. So due to heat, whenever there is an increase in the heat, the oil in the transformer will get expands and contracts whenever the temperature decreases. So function of the conservator is to take up the expansion and the contraction of the oil. So oil is get expands whenever there is a increase in the temperature inside the transformer and the oil is get contract whenever there is a decrease in the temperature of the transformer. And next is a breather. Breather was a smaller transformer not fully filled with the oil. So there will always be some space between the oil level and the tank. The tank will be connected to the atmosphere by the vent pipe. So when oil expands, air will go out, and when oil get and the air inside, when oil expands, air will go out, and when the oil contracts, air is get taken in. So the function of a breather, it extracts the moisture from the air when air is taken in and does not allow oil to come in contact with the moisture. So it contains silica gel to absorb the moisture. And next is the explosion vent. It is a pipe fitted on the main tank. It acts as a relief valve. So it bursts out when pressure inside the transformer becomes excessive. It releases the pressure and protects the transformer. And final one is a Butchol relay. It is a safety gas operated relay connected to the transformer. When faults get developed inside the transformer, the gases get released by this Butchol relay, and the trips of the circuit breaker to protect the devices. So that's all about the construction and working principle behind the transformer. Thank you.